Hello everyone. In this video, we'll be talking about APIs and Picos. The main purpose of this video is to fill your toolbox with more tools when it comes to developing on the Pico engine. This video will cover four things. Let's cover the testing tab. We'll talk about where to find it and how to use it. We'll cover def actions, what they are and how to declare them. We'll cover modules, what they are and how to declare one. And we'll also talk about HTTP. And that's so that you guys can learn how to call an API from a Pico. So let's get started. The Pico Engine UI makes it easy for you to test any events or queries on a particular Pico. All you have to do is go to that Pico, and on the far right, you'll find the testing tab. Here you'll see any rule sets that you currently have installed on that Pico. So let's say we wanted to test some functions and rules that we've written on the test rule set. We'd open it up, and here you could find any functions or rules you've allowed to be tested. But it's not as simple as just writing the functions or rules. That won't just allow you to test them. So let's take a closer look at this underscore testing here. If we were to click on it, you'll see this map that contains queries and events. And I don't know about you, but this looks a little familiar. See the name entry in the arguments key. You can see that right here. This little box shows that I can write the value for the argument key, and I can hit entry. So if we were to take a closer look at this rule set, which I have open right here, we can see here's my function that I wrote, and it has the name entry in the argument key. And if you look even further up, we've got this underscore testing, and that same map, it's found right here. So for you to have your function to show up in under that rule set that it's respective to, you need to have it be part of the value that is bound to the name underscore testing. You'll see right here that I have this map, name entry arguments key. So that allowed me to see it here under test. So really the Pico Engine UI is just calling this underscore testing and displaying its contents very nicely right here, like you saw here. And so not only do you have to do this, like we talked about, but this underscore testing needs to be in the shares pragma. You see here that I wrote shares and then underscore testing. This allowed for underscore testing to be called from outside of the Pico itself. And so that means any functions that you want to be queried also have to be in the shares pragma. Because if you didn't do that, all you would get is this nice little UI here, but it wouldn't do anything. You could never call that function. You could never query the Pico. So let's talk a little bit more about the testing tab and talk about some helpful tips that'll help you in your testing. So a common mistake a lot of developers will make when testing their functions is they'll think that if they don't pass in a value in one of the parameters, if they don't write anything in the input field, that the Pico Engine will take that as null, and that their function will be run with that parameter being null. That's actually not the case. If I were not to put anything here for this function, key would actually come in as an empty string. And so that can change the way the function is treated. So let's look at the function here. So we got key right here. And what we're going to do is we're going to return a map that will show what was passed in as a parameter. We'll check to see if it's null. And then we'll see what the Pico Engine evaluates it in this ternary operator. So the empty string, right, we'll see this be an empty string. We'll see it evaluate. We'll see this evaluate to false, right, because it's not null. And the Pico Engine will actually evaluate the empty string as false. So we should see that, right? If I don't pass anything, which is what I'm claiming is that the Pico Engine will see this as the empty string if I just run it without putting a value. We'll see what I just said earlier to be true. So let's do it real quick. I'll run it. You'll see right here, the empty string is passed in. And this was false because it's not null. And the Pico Engine evaluates the empty string as false. So you might say, well, then how do I test a function and have it pass the parameters null? What you could do is write another test for it right here and add it to the value that's binded to the underscore testing name. So we'll write name, call it entry, just add the quotes, and then we just won't pass any arguments, right? So now the function will get called, but we won't pass any argument for key, so it should evaluate, should have key to be null. So we'll refresh real quick, look at the testing tab, and now we'll see that there is no input field for a key. And if we run that, it was passed in as null, key.isNull was evaluated to true, and the ternary operator evaluated null as false. We can even test it with an actual value. Say I just pass in Pico, right? We see different results. We see Pico as the value. It's not null. And the Pico engine evaluated this string as true. So just keep in mind that when you write your test for your functions, you gotta remember whether, you know, passing in the empty string or null is something that you look for. If it's something that you want to test, you need to make sure that you write your test in this way. You remember that the empty string is not null, and just not filling in that value in the input field will not make it null. In fact, it'll just have it be the empty string. Hello everyone, in this video we also wanted to cover diffractions, what they are, and how to declare them. You can see right here I have an example of what a diffraction should look like. It looks very similar to a function, right? It receives parameters and you can do declarations inside. The only difference is a diffraction actually has an action block. You can see right here I have an example of a diffraction, and I'm making use of a compound action right here where I'm able to run more than one action. So this is great, right? Diffractions are great for data processing and running multiple actions. And just like above, I can even do something like this. I can call the function that I have written up above, and that is totally valid. So I can do things right before the actual actions that I want to run. And that could be helpful, right? There's many use cases for that. Another great thing about diffractions is they're great for abstraction, right? If this is an action you're going to do multiple times throughout the rule set, might as well abstract it into a diffraction, and then you can get rid of code duplication and you have single responsibility. And that's easy. That makes it easy for you to do stuff like this, right? In this rule, I'm able to just call send warning. And then if I write another rule, it's going to do the same thing. I can do that again without having to rewrite all of this. Lastly, diffractions are amazing for modules, and we're going to cover that next. Okay, so we wanted to talk about modules and what they are and how to declare one. If you read the modules and external API lesson, which we'll link below, they make a comparison of modules to packages and libraries, right? Like the ones you include in C++ or import in Java. You know, when you make a rule set a module, you allow it to provide functions and diffractions to other rule sets. Just like when you use a library, you can call functions that are written somewhere else. And so you can almost see yourself making a rule set a module because it's an external API wrapper, right? Like maybe you make a whole rule set that has these diffractions and functions that make API calls, and now you can let other rule sets call those functions and diffractions, and that's great for abstraction and making sure there's no code duplication. And another use case for having a rule set be a module is, let's say you're currently writing a rule set that depends on the result of some function that's written on a different rule set, and both of these rule sets will be on the same Pico, and you'll be calling that function on that Pico. You don't want to the rule set that you're currently writing, you don't want to have the Pico query itself. That's bad because Picos are single threaded. What you want instead is to have that rule set that contains the function be a module and provide that function for the rule set that you're currently writing to use. And so that's like another great use case. You never want a Pico to query itself. So let's show how you can have a rule set use another rule set as a module. Let's say right now I'm on test 2. Let's say I want to use test as a module, right? So I'll just say use module test. You can also give an alias to test, because every time I want to call function or def action in test, I have to write test : the name of the function or def action. But if I don't want to write that rule set name every single time, like for example, let's say I'm using io.picolabs.wrangler as a module, I don't want to write that every single time. I can give it a shorter name, and we'll do that with test. So you want to write alias, we'll just call it T. So now I can refer to the test rule set as T. So I'll just register that. So unless test is providing any functions or def actions, unless they're doing that, then I can call function def actions if they are. If they're not, then I can't call anything. It's useless. So let's see if test is providing any functions or def actions, and it's not. So really, that module, using test as a module, would be pointless. But let's say, right, I have one function right here. It's called isValid. All it does is receives a value, a parameter, and I check to see if it's null or the empty string, right? If it's null, it'll come out false. If it's the empty string, it'll come out false. Else will be true, right? So let's say I want to provide that. I'll just write provides is valid. So let's say this truthy and falsy, right? Let's say I want those to be these constants that anyone can use. I can configure this rule set to be using certain values for that as default, right? So let's say truthy and falsy, it's falsy, right? So now these names that are binding these values can be used in my rule set, but that's how it's configured by default. When this is being used as a module by another rule set, they can configure the module however they like, and that's perfect because maybe one rule set wants different values to be returned depending if the parameter is valid, right? Right, by default, we'll be doing truthy and falsy, but maybe my test 2 would want to use actual Boolean values instead of string values. So letting a rule set have value or names like these be configured it's got tons of use cases, right? So let's go to test 2. So let's say I want to use the test module with the truthy and falsy names to be binded to actual Boolean values. I would do with truthy equal to true and falsy equal to false, right? So now I'm using the test module to my own use case, right? Someone else can keep them as strings or not configure them and just use the default configuration of truthy and falsy. So now I can use test as a module. And so I have this rule right here that I wrote beforehand to test using the test module. And I'll be doing it through the testing tab. I even wrote this beforehand so that I can use it in the testing tab. So let's say right here, I'll be calling the module function is valid. So is valid. See, so I'm referring to the test module is T. I'm calling the is valid function. And then I'll be passing in param. Right. And if is valid returns true, right, I configured it with true, then I'll get a good param. I configured false to be false, so if this param, right, if I put in null or the empty string, then it should pass in the parameter, and that should get false, right? And you'll see this working because if I were to just get the string falsy and I give it a bad parameter, I would end up getting true anyways, right? But I'm actually using the Boolean false. So let's try that out. So I'll first do with the empty string. I get this bad parameter, right? Let's say I do hello, good parameter, right? I'll do the empty string again, bad parameter. So that's an example of me being able to use that function in test without having to write it in my test too, right? Hopefully this helped you see a good use case for modules and how to use them.
Okay, so I want to talk a little bit about HTTP and the library that is included in the Pico engine. Something you can use with your KRL rule set. So this library has a couple different actions and functions. So you can do all the HTTP methods and you can do them all as actions, and then the only one you can do as a function is the get. So let's do an example of that. So we're going to use this API, this deck of cards, and we're going to simulate just a casino where you can shuffle a deck of cards and draw from it. So you'll see I have here my casino Pico, and there are a couple functions here. Let me pull over the code and we're going to analyze this a little bit. So first I want to show you guys how to use the HTTP library as a function using the get, and then also as an action, and we're also going to be using get just because that's what this API gives us. And so first thing is with this API, they give you this URL to shuffle a deck of cards and get the deck ID. And so if we come back here, I'll show you guys I have this one function. It's get deck ID, and this is the the part from the HTTP library. All it is HTTP get, and the parameter is a string, which would be the URL. There are a few other parameters that you can include in here, and I'd like to encourage you guys to go and check out the KRL manual and read into that and play around with it to really get a better idea. But we're just going to briefly go over a few things. So after this here, I'm going to comment out that. Let me flush that. And you guys can see what this function looks like. So when I do get deck ID, you'll see it returns to me a content type, just a normal HTTP get what the request would return, the response. And so the part that we're interested in is getting this content. And so coming back here, let's just include the content and we'll leave everything else out for a second. Let me flush that again. Now when I press get deck ID, you'll see I get the content, but it's actually just a string. It's a JSON object, but only a string right now. So in the KRL manual, if you come in here, you can see there's a way to decode JSON. And so it's just the dot decode. So that's what we have here. And then the only part of this that I'm interested in is the deck ID. You'll see it returns. You'll see it returns a lot more than that, but all I'm interested in is his deck ID. So we're just going to be grabbing that. So let me make sure I save that and flush it. And now when I do the get deck ID, you'll see it just returns the deck ID. So let's come back here. That's how I would use that as a function. Now, if I wanted to use it as an action, I'll need to do it in a rule in the action block. And so, yeah, let's look at the draw card. You'll see if I have a deck ID already, then this rule will fire. And all I do is another HTTP get, but then I do the setting response. Now what that does is it sets the response to this, it binds it to this variable response. And then as soon as I get a response, I raise this casino event save card with that response or the content of that response as an attribute. And I raise the next rule. The next rule will then grab that and then just add it to my hand. So if we come back here, you can see my hand, my cards, it's just an empty array. But if I do get deck, now that deck ID is saved. If you come here, you can see in my entity variables, I have one. So this rule will fire. And then if I were to draw a card, and you'll see now I have the 9 of diamonds, draw another card, got the King of Hearts, just like that. So the HTTP rule is really simple. You just have to pass in a string. Make sure you include the method. If I were to want to do a post, you just do it like that. And there are various different things that you can include: post, put, patch, delete, get. And that's really all there is to the HTTP library.